In this video, we're going to talk about control circuits and potential dividers. So control circuits is all about introducing components into a circuit in order to make them respond to external changes. So there's two things that we look at. We look at thermistors, which respond to changes in temperature. They're basically heat sensors. And the graph of resistance against temperature looks a bit like this. So students don't need to know mathematically what this relationship is. It's not inversely proportional. They just need to know there's a curve, and as temperature increases, resistance decreases, or the reverse. We also look at light-dependent resistors, or Ldrs, which are light sensors, and we have graphs that look like this: resistance against light intensity. And again, same kind of thing. There will be a curve like this. So what are some uses? So things like central heating, thermostats, things like air conditioning sensors, street lights here. Now, what is quite interesting is none of the simple circuits I'm going to show you are anything close to what would be used here. It's a massive oversimplification, but it doesn't matter. The general principle is fine for GCSE and fine for students. So how do these actually work in a circuit? Well, we need to introduce this idea of potential dividers. So all potential dividers are ways for sharing the potential or sharing the volts. So we have a battery. We have two things in a circuit. We'll call this resistor A. We'll call this one resistor B. And what's going to happen to the potential difference? Well, there will be some potential difference across here, and then there will be some potential difference across here. And we know that it's just a simple ratio. So if we put some numbers, if we said the cell was, 6 volts, we said this was 5 ohms, and this was 1 ohm, then this would have 5 volts, and this would have 1 volt. We could look at more complicated examples with 3 resistors, 10, 100, and 1,000. For example, the ratio that the volts would be split would be 10 to 100 to 1,000. So you would just do something like 6 volts divided by the total, and then times by whichever one you want. So if you wanted the potential difference across 10 volts, times it by 10. If you wanted the 6 volts and you wanted to know how much it was across the 1,000 one, times it by 1,000, just like you would solve a ratio problem. Okay, only something I think you'd expect to do at higher tier, and certainly the vast majority of questions in lectures tier are actually more simple than this. So the question is instead of having a voltmeter, if we replace this with, for example, a heater or a light, then would it turn on, or when does it turn on? So in order to answer this, we need to really think carefully about what's going on in the circuit. I'm going to redraw it like this just because this is often how we see it. So let's look at the thermistor first of all. So we typically care about the V across the component, but it could be switched, in which case we'll have to think it through. So here, when it's hot, the resistance across the thermistor is low, so the voltage across it is low, and when it's cold, then the resistance is high and the voltage is high. So here, if we replace this with a heater, for example, then the heater would turn on when it's cold. If you put the V out over here, if you put the voltage out over here, then it would do the reverse, and it would have a high voltage, high potential difference when it's cold, and a low potential, high potential difference when it's hot, low potential difference when it's cold. Because it's going to get the opposite percentage difference to whatever this one's getting. With a light dependent resistor, same kind of idea. Let's draw our circuit. Well, I've got the arrows up here. Again, if we do our V out here, and we had, I don't know, a security light, then when it's light, so when it's daytime, the resistance is low and the V is low. At night, then the resistance increases, it becomes high, the V becomes high, and the light would turn on. There's really not that much more to this topic than this. It is really quite basic, but it is worth just switching around these components just to try and catch students out, just to make sure they really understand it and aren't just memorizing it, just in case the exam question is a little bit different.